Now we're going to look at how the inputs, like capital and labor and things like that, are distributed between firms. And we're going to look for input efficiency, that is an allocation of inputs, so that there's no way to sort of reshuffle those inputs. Maybe one firm trades capital for the other firm's labor. There's no such trade that results in one of the firms producing more of whatever it produces, unless the other firm produces less of the good that it makes. Right? If there is such a trade of these inputs that results in us getting more of one of the good and no less of the other good, then that initial allocation of inputs would not have been input efficient. So that's the idea here. I want you to recall, before we look at this problem, that there are multiple ways of making a product. I had given this example of digging a hole. You could either have a lot of labor and relatively cheap capital, just a number of shovels, or you could have a lot of capital, like a big digger, a machine that people drive that actually digs in the ground, and only one worker. And so we want to look at when an initial allocation of capital and labor and other inputs is such that there's no way to reshuffle those inputs across the firms that results in one of them making more of whatever it produces and the other firm making no less. You might guess we're going to use the Edgeworth box diagram again. Okay, this time we're going to have isoquant graphs. So here I have two isoquant graphs, one for Ford and one for Samsung. Let's look at the one on the left for Ford first. Okay, remember, for these isoquant graphs, we're going to have the amount of capital on the vertical axis typically. So the further you move up this graph vertically, it involves more capital for Ford. And labor is going to be shown on the horizontal axis. So as you move further to the right, it's going to imply more labor for Ford. And as you move up and to the right, it involves more of both capital and labor for Ford. Now you might also recall that we plotted isoquants. So an isoquant represents all the different combinations of inputs that imply the same total output. So every different combination of inputs, amount of capital and labor, that falls on this isoquant line results in the same number of cars being produced by Ford, including this point here, which is a lot of capital, not that much labor, and this point here, which is a lot less capital, but a lot more labor. All of these points on this curve produce the same amount. We might also draw the isoquant graph for Samsung. Right? Again, we have capital on the vertical axis, labor on the horizontal axis. And we have this isoquant here, which represents all the amounts of capital and labor that lead to the same total amount of output. And isoquants that lie further up and to the right imply higher total amounts produced by Samsung. We're going to use the Edgeworth box diagram again because we want to combine these graphs in a meaningful way that accounts for scarcity. If one firm gets more capital, it necessarily means the other firm is getting less capital. And to create this Edgeworth box diagram, we're going to do the exact same thing that we did when we were looking at exchange efficiency and using the indifference curve graphs. What we're going to do is we're going to take Samsung's isoquant graph and we're going to rotate it and flip it. Okay, so let's see that again. We're going to take Samsung's isoquant graph and rotate and flip it. And once we've done that, you can see that any point on this Edgeworth box diagram represents how much capital and how much labor is allocated to each of these two firms. As you move vertically upwards, it implies that Ford is getting more of the capital and Samsung is getting less of the capital. And as you move horizontally right, it implies that Ford is getting more of the labor and Samsung is getting less of the labor. Okay? So we're going to draw a bunch of different parallels. You're going to see that we're going to be talking about a slightly different thing because now we're talking about inputs to firms, but a lot of the same reasoning is going to apply. Now you might guess, when is there input efficiency? Well, it's when there's no way to reshuffle the goods that involves making more of both of the goods, or it'll be more of one of the goods and less of the other. So if we were to shuffle the inputs, let's say we start at this allocation of inputs here. If we were to shuffle and move to this point here, we can see at this point falls at a point that's up and to the right of these blue isoquants that in the graph before would have corresponded to Ford, and down and to the left of Samsung's isoquants. So it involves both Ford and Samsung making more of the goods that they produce. Okay, so whenever you have the isoquants that cross, there's going to be some area between them that involves both firms making more of what they produce. Okay? So what is the condition going to be for input efficiency? It's going to be when the allocation of inputs is such that the isoquants for each of the two firms are just tangent and have the same slope at that point. Okay, so point G would be an example of input efficiency. Now remember that the slope of the isoquant, it's the magnitude, is equal to the marginal rate of technical substitution, MRTS, or the rate at which inputs can be traded off in the production process. Okay, so the condition for input efficiency is that both firms have the same marginal rate of technical substitution, same slope of the isoquants at that point. Okay. And again, we're going to see that there are a lot of different efficient allocations. So the production contract curve shows all the combinations of allocations of inputs that result in an efficient allocation of inputs. Right? So there's some allocations down here that result in one firm making very little of its product and the other firm making a lot, and vice versa for points up here. So we're going to come back to that. Input efficiency is not going to tell us whether we're making the right basket of goods. It's only going to tell us whether the inputs are being efficiently allocated between the two firms. Okay. So again, prices are going to facilitate efficiency. Both of the firms are going to choose inputs such that the marginal rate of technical substitution is equal to the ratio of prices of the two inputs. And if one of the inputs is too cheap so that there's excess demand for that input, there should be sort of this bidding up process. All firms are going to sort of offer a little bit more than the going rate to try and get that input. And it's going to continue to be bid up until the price is such that the demand for that input from the firms is exactly equal to the amount of that input that's in the market. Okay, so again, a free market under typical circumstances should facilitate input efficiency. Okay, so when won't input efficiency hold? Well, it won't hold if one of the firms is a monopsonist and the other is a firm in a competitive market. All the competitive firms are going to set the marginal rate of technical substitution equal to the ratio of prices, because they're all just taking the input prices as given. So there's some going wage or some price of capital. They're all going to set their marginal rate of technical substitution equal to the ratio of input prices. But for a monopsonist, the amount of labor that they hire is going to determine the wage that they pay. And for reasons that we described earlier, the marginal amount they're paying for an additional unit of labor is not equal to the wage that they're paying that additional worker. It's equal to the marginal expenditure, which for a monopsonist is different than the wage that they're paying that last worker. So you're going to have a monopsonist setting the marginal rate of technical substitution equal to the marginal expenditure over R, where marginal expenditure is something greater than the wage. Whereas firms that are operating, in competitive market that don't have any impact on the wage, they're going to set the marginal rate of technical substitution equal to W over R. So when you have a monopsonist firm and some firms that are not monopsonists, you're going to get them setting the marginal rate of technical substitution equal to different amounts. And so if you have that scenario, you're going to not have input efficiency. Now you can see where this might be going. We're looking at where this type of efficiency fails and where government regulations to fix these market failures might be appropriate. So for example, maybe we want to have minimum wage laws so that monopsony firms have a marginal expenditure that's equal to the wage rate so that different firms have the same marginal rate of technical substitution, which implies that there is input efficiency.